Okay, so more with power factors or lagging and leading currents. So we have another problem here where we have a single phase 60 hertz circuit. The source voltage is given as 115 with an angle of 0 volts. The load voltage is composed of a 2 ohm resistor in series with a 3 millihenry inductor, and the source impedance ZS is equivalent to 0.2 angle of 40. So let's find ZL. Let's start with finding ZL. ZL is going to be equal to, well, given 2 ohms plus our 3 millihenry, which is equal to, in this circuit, because we have the 60 hertz, we have 2 pi times 60 times 0.003, which ends up being J 1.131 approximately. So our load is 2 plus J 1.31, which is also equal to 2.298 angle 29.49 degrees. So we have that given. Now let's find what our VL, so our VL is going to be this value right here. And using it, the load voltage is going to be just like we would if it was a DC circuit, where our VL is equal to, using Ohm's law, oops, sorry, my hand touched that. Is equal to ZL, which again we found to be this value here, divided by ZS, which was given, plus ZL. And there are other ways of finding this, but I mean, this is simple enough. And then times V all times VS, which gives us 105.9 angle negative 0.8381 degrees volts. So that is this is our value if you would stick your probes on one side, on either side of this inductor or this load. So then our IS, we want to find the total complex power. I'll leave that formula on there for people to see. So the next part B says find total complex power delivered by the source. So our IS, we need to, in order to find complex power, we need to find IS, which is equal to VS divided by ZS plus ZL, which is equal to 46.10 angle negative 30.33 degrees amps. So then our S, or our complex power, our volt amps, is equal to VS times IS conjugate, which is equal to 5,302 angle 30.3. $30.33 VAs. So that is our total complex power delivered by our source right here. So that's our answer to part B. Now we want to find the power of the load, power consumed, part C, active power consumed by the load. So PL, power of the load, is equal to the real part of SL, which is equal to the real part of IL squared ZL. So we can find this out by equals to IL squared times the resistance of the load. This is just our simple P, our power, or our power is equal to current times voltage, but in this case we're substituting to get our IL, which we found to be 46.1 angle negative 30.33 degrees, the whole thing squared, times our RL, which is going to be, as we found earlier, 2 plus I 1.131, which is then which is then equal to putting in the calculator right now.
And John Brennan's case is not alone. Though some say he is a murderer, others are convinced he is not. For John Brennan, this debate is really a matter of life and death. After suffering 500,
The solution comes out to be
because he is a convicted murderer, the operation he needs to survive. This, John Brennan's
4.25 kilowatts.
during the mid-60s, Martin Luther King dreamed his dream to be father. John Brennan marched by his side.
And
Personal position. Chicago was a racial battle.
then our power factor for the load, part D, is equal to cosine 29.49. Wish it wouldn't assume I was trying to connect these lines. Which is equal to 0.8704 lagging.